Okie dokie, so now we're going to add and subtract rational expressions with unlike denominators. This creates just a little bit of extra work, but I think all of you can handle this. All right, so you might want to read through this or maybe jot this down. So the first thing you want to do is you want to factor each expression completely, all right? Make sure you get your GCFs out, make sure you factor it to the lowest possible form. And then you want to get rid of your like factors so that you're not having to deal with them whenever you're trying to find your common denominator, okay? So if you have any, you won't always have any, but you might, okay? So then you want to bring down the columns, and I'll show you what I mean by that, and then you want to multiply your factors. And so always, 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 this is one of those things that we need to exclude values that would make the denominator 0. So what values of x should we exclude in this next example? Let's take a look. All right, so for this, one thing I want you to notice is that LCD stands for lowest common denominator, right? Do we really care about the numerator in this case? Well, not right now. Right now, we're just looking for the denominator, the common denominator between these two. So that's why I'm just going to focus on the denominators, okay? So I'm going to factor this and I'm going to factor this, all right? So our LCD will be all of the factors put together, okay? So we're going to factor the denominator, and the one on the left factors to be x minus 3, x plus 1, okay? The one on the right, it factors to be x plus 3, x plus 1. Now, notice that they both have an x plus 1, okay? That's cool. All right, so our LCD will have an x plus 1 in it. Now, this one has an x minus 3, but this one doesn't. This one has an x plus 3, this one doesn't. This one has an x minus 3, and this one doesn't. But you have to have at least one of every single factor that's listed, okay? So you don't need two because each of these terms only has one x plus 1. So that's why we only have one x plus 1 here, okay? If we had two x plus 1s in one of these, then we'd have to have two. But since each one has only one, we only need one x plus 1. All right, so now the other piece we need is we need x plus 3, and we also need an x, I need a minus sign there, x minus 3, okay? So we had to take every single piece. So what you want to do is you want to look at, is this listed in my LCD? Yep. Is this listed in my LCD? Yes. Is this listed in my LCD? Yes. Is this listed? Yes. Okay. So our LCD is, and really I don't need this line because all they're asking us for is the LCD, is this business right here. We're not going to write the fractions just yet. We're about to. So right now they're just asking us what the LCD is. All right, so remember that last example where we found this LCD? Well, now we're going to rewrite each of these as equivalent rational expressions with this denominator. Okay, so I'm going to rewrite the first one in factored form. I'm going to rewrite the second one in factored form. And we know that our LCD is these three terms here, x plus 1, x minus 3, x plus 3, and really it doesn't matter which order you write those in. All right, so now let's take a look at this top one, okay? We've got an x minus 3, it's already got that. We've got the x plus 1, it's already got that. What is this missing over here? It's missing the x plus 3. So that means I have to multiply by x plus 3 to get the LCD, which means I also need to multiply the numerator times x plus 3. Remember, x plus 3 divided by x plus 3 is 1. All we're doing here is multiplying by a version of 1, okay? Now, check out the bottom one. What are we missing? We're missing the x minus 3, right? So we're going to multiply the top and the bottom by x minus 3. Okay? So our numerator right here now becomes, I've got to distribute though. You guys be really careful with this. Make sure you're distributing. So I end up with 8x plus 24 right there. And in the bottom one, I end up with 3x times x is 3x squared, and then 3x times negative 3 gives us negative 9x. And that's it. We have just rewritten these as equivalent rational expressions with a common denominator. Now at this point, we could add or subtract these numerators if we wanted to. But they're not asking us to do that. They're just asking us to rewrite them. All right, quick example, going back to your younger years, whenever you were first learning how to add and subtract fractions. All right, so what is our common denominator between 12 and 18? It is 36, right? Okay, so what do you have to multiply 12 by? I thought I was using my pointer. What do I have to multiply 12 by to get it to be 36? I've got to multiply by 3, right? So what I do to the bottom, I have to do to the numerator, correct? That's what I've been telling you this whole time. So we've got to multiply by 3 over 3. Now what do I have to multiply 18 by to get it to be 36? 2. So that's 2 over 2, right? 2 over 2 is 1. 3 over 3 is 1. Okay, so now my numerator ends up being right here. My numerator on the left ends up being 21. My numerator on the right ends up being 10. And now we're allowed to add the numerators together. And that's as good as we can get this problem. All right, just a reminder how to do a problem like this. Okay, so first of all, let's look at the 12 and the 21. So what is the smallest number that 12 and 21 can both go into? Here's how I do it. You may do this a different way, and that's okay as long as we end up with the same thing. But I take my larger number, which is 21 in this case, and I list out multiples of 21. So 21, 12 won't go into 21 evenly. So now 42, 12 won't go into 42 evenly. 21 times 3 is 63. 12 won't go into 63 evenly. 21 times 4 is 84, and 12 will go into 84. Okay, so I know I want 84 and 84. Okay? Now, look at this. I've got 2 x's here, but I only have 1 here. Remember, this can't get smaller, but this could get bigger. Okay? So we have to have 2 x's in our denominator. They can't get smaller, they can only get bigger, okay? Now look at your y's. I've got 1 y here and I've got 2 y's here. This can't get smaller, but this could get bigger. So we want 2 y's as well in the denominator, okay? All right, now we want to look at each piece. So over here, I've got to multiply by a version of 1, okay? So ask yourself, what times 12 would give me 84? Well, that is 7. So I know I need at least times 7. 7 over 7. Okay? Now, look at your x's. Do I need any more x's? From here to here. No, I have the right amount, so I don't need any more x's. What about y's? From here to here, I need 1 more y. So I need 7y over 7y. Okay? Now, so that would make my numerator 35y. All right, let's look at this one. From 21 to 84, I know I need to multiply by at least 4 over 4. Look at your x's. From here to here, I need 1 more, don't I? X over x. Do I need any more y's? Nope, I don't need any more y's. So I end up with 16x in the numerator. Okay? Now, we have a common denominator. So we're totally cool there. So my denominator is going to be 84x squared y. And my numerator is going to be 35y plus 16x. Now, do these guys right here have anything in common that I can factor out? And they don't. I don't see anything. So really, this answer is the simplified form of this answer. Real quick, and one of your wonderful classmates caught this. I failed to put the square term right here for the y. So really that should be y squared. That is correct. And the other thing that I want to tell you too before I move past this page is that this can actually be written as okay, so both of these are interchangeable and they are the same. Some people will say that they prefer the x term to be in front of the y term. It honestly does not matter. We're allowed to add in any order according to the commutative property. So it doesn't matter, but I'm just letting you know that this answer and this answer are the same. And I will say good catch to the student that caught that I failed to put the y squared there. All right, so how to add rational expressions with different denominators. The first thing that you want to do is you want to factor. Well, these are already factored. So the next thing you want to do is you want to figure out what your LCD is. Well, I think that our LCD in this case is going to be x minus 3 and x minus 2. Okay? Do you see where I got that from? Because they don't match, I've got to have both of them in my LCD, okay? So now my numerator over here, I need to multiply by what is missing. So x minus 3 from here to here, I've got that part, but I'm missing the x minus 2 part. So I need to multiply by x minus 2 over x minus 2. Over here, I need to multiply by x minus 3 over x minus 3. Okay? So now I'm going to go ahead and distribute. So I end up with 3x minus 6 in the numerator there. And then I end up with 2x minus 6 over here. Okay? So now what we end up with is we do have a common denominator, so let's go ahead and add our like terms together in the numerator. 3x plus 2x is 5x, and then we've got minus 6 plus minus 6, which is minus 12. And then our denominator does not change. And I can't factor the numerator, so I think this is as good as this answer gets. All right, if you need a step-by-step, you might want to hit pause and write this down. Otherwise, you can just keep following along in the video. I will be performing all of these steps in each problem that we do. Okay, so step number 1 is to factor everything that can be factored. Actually, factor everything in the denominator that can be factored, okay? So in the denominator down here, I'm going to factor out, I'm just rewriting the numerator, I'm going to factor out a b. So then I have 2a plus b right there, plus 3a. And then in this one, I am going to factor, oh, that's a difference of squares. So I would end up with 2a plus b and 2a minus b. Okay, so now we need to come up with our LCD. So our LCD, remember, has to have each piece, okay? These match, so I only need one of those, okay? So I need a b, I need a 2a plus b, and I need a 2a minus b, and that's my LCD. All right. Now let's look at what we're missing. Okay, from here to here, we're missing 2a minus b. So we're going to multiply by 2a minus b in top and bottom. I say the bottom, we've already done that part because we wrote it down here. Okay, over here, what's missing? The only thing that's missing, I've got that, I've got that, I've got that, I've got that, I'm missing this. So let's multiply by b over b. All right, so my numerator on the left becomes 4a squared minus 2ab. My numerator on the right becomes 3ab. All right, so now let's combine our like terms. So it looks like our like terms are here and here in the numerator. All right, so I end up with 4a squared plus ab over b times 2a, oops, I forgot to put my plus sign there. All right, now, this whole time I've been telling you that you need to factor and get rid of like factors, and I'm not lying to you. I'm just saying that it really won't help us in this case, but let me show you. Okay, so my numerator, now I'm going to factor my numerator, and I can only factor out an a. That's it. And so there's nothing to mark out, nothing matches. So we did factor it, it didn't help us, but you always want to factor your numerator after you're done combining your like terms because you want to see if there are any factors that, that will mark out. Okay, on to the next example. Let's rewrite these in factored form. So I've got 8, and I've got, let's see here, x minus 3, x plus 1, and then I've got 3x over x plus 3, x plus 1. So remember, our LCD has to have at least one of every piece, right? This and this match, I only need one of those, okay? So we would have our LCD at x plus 1, x minus 3, x plus 3. All right, so let's take a look at what's missing from here to here. We're missing the x plus 3. So I want to multiply by that version of 1, which is x plus 3 over x plus 3. From here to here, we're missing x minus 3. Let's go ahead and distribute. So on the left, I get 8x plus 24. On the right, I get 3x squared minus 9x. So now that I have a common denominator, I can combine my like terms, and my like terms are right here and here. So I'm going to write this in standard form. So I get 3x squared minus x plus 24 over x plus 1, x minus 3, x plus 3. Now, I need to see if this numerator is factorable. So I'm going to multiply this times this, and I get positive 72. And I want factors of positive 72 that add up to be a negative 1. That means both factors have to be negative, okay? So negative 1, negative 72, that doesn't work. Negative 2, and negative 36, that doesn't work. Let's see here, negative 3 and 24, negative 24, those don't work either. 72, let's see here, negative 4 and negative 18, nope, those don't work either. 6, negative 12, nope. Negative 8 and negative 9. Oh, those would be the ones if the signs were correct, but it's not. So there isn't. There is not any. Now that I've gotten to where I'm repeating the things on the left because the next number would be -9, I've already got that over here. So I know that I've listed every single pair of factors. So that means this numerator is prime. There are no like factors that we can cancel out with the denominator. So this really is the best and most simplified answer that we can get. Okay, so how is subtraction different than addition? It's really not that different. The only difference is you have to distribute that minus sign to the numerator immediately following the subtraction sign, okay? So you're still going to find your common denominator the same way. So I've got x over x minus 3, and I'm just writing this so it's bigger. So what is my LCD? My LCD is x minus 3 and x plus 3. Okay, so what am I missing from... Oh, God, I did it again. Good heavens, I should stop recording. Okay, so from here to here, I need an x plus 3. So I need to multiply by x plus 3 over x plus 3. Okay? From here to here, I need an x minus 3. All right, so now let's distribute. The harder one is going to be this one over here, because remember, we've got to find that middle term. Whenever you have a binomial times a binomial, you're likely going to have a middle term. So on the left, we're going to have x squared plus 3x. And on the right, we're going to have, let's see here, x squared minus 2x minus 3x plus 6. Adding those up, we get x squared minus 5x plus 6. Okay? Now we want to distribute this minus sign. Change, change, change. That's a plus. Change. That's a minus. Minus 6. Okay? All right. Now, let's combine our like terms. So in the numerator, the x squareds cancel. Okay? Positive x squared and negative x squared cancel out. Positive 3x plus positive 5x gives us positive 8x. And then we've got minus 6 over x minus 3, x plus 3. And what have I been telling you this whole time? You need to factor your numerator at the end so that you know if you can mark out or cancel any like factors. So let's factor out a 2. It didn't help us. I wanted it to so bad, but it didn't. So this is as good as this answer gets. All right, again, just if you need to write this in your notes, you're welcome to do that. Hit pause at this point. I'm not going to read it to you, but it's everything that we have been doing to solve these. Okay, let's take a look at this one. I'm going to rewrite these in their factored form. So I've got 8y over y minus 4 and y plus 4. Okay, minus 4 over y minus 4. Okay, so what is our common denominator? Our common denominator has to have these match, so it needs one of those, and it needs one of those. Okay, remember, denominators can only get bigger. They can't get smaller, all right? So our LCD is y minus 4 and y plus 4. Okay, so take a look from here to here. Do I need to change anything at all? Nope, I sure don't. So I'm just going to have 8y in that numerator, okay? Now, from here to here, I need y plus 4, don't I? So I'm going to multiply by y plus 4 over y plus 4, okay? So my numerator becomes 4y plus 16. Now, I need to distribute this minus sign. So minus, that becomes a plus, this becomes a minus, this becomes a minus. Okay, so now let's combine our like terms in the numerator. I've got like terms here and here. So that becomes 4y minus 16 in the numerator. Let's factor our numerator. I can factor out a 4. Ooh, look at that. That helps. And now I can cancel out my like factors. And I'm left with just 4 in the numerator and y plus 4 in the denominator. And why can't I mark out these 4's? Because this 4 happens to be married to this y. Okay? You can't mark out or cancel out factors or addition. It's got to be factors. And remember, by the word factor, I mean multiplication. Okay? So this is addition. You cannot mark things out that are using addition or subtraction. Only multiplication. Okay, so take a look at this one. I'm going to rewrite these in their factored forms. Now, I don't factor my numerators until the very end. So I am not going to factor this piece right here, okay? Because I want to be able to combine my like terms, and I can't do that in a factored form. Okay, so I'm just rewriting negative 3n minus 9. And this denominator I am writing as n plus 3, n minus 2. Okay? N plus 3 over. Now, does that not look funny to you guys? Let's put those n's in the front. So we've got negative n plus 2. But look, isn't this opposite of that? So let's multiply by negative 1. Remember whenever we did that in the last video? Okay, so actually I'm going to change my numerator over here. All right, so my numerator becomes negative n minus 3, and my denominator becomes n plus 2. Do you see why? Negative 1 times a negative n gives me a positive n. Negative 1 times positive 2 gives me a negative 2, Stacy. Silly. You guys, I will tell you that it is a bad idea to try to power through math when you're tired, because that's me right now. I am exhausted. Okay. What is our common denominator? It is n plus 3 and n minus 2. Okay. Now, looking from here to here, am I missing anything? No, I'm not. Okay, so I'm just rewriting my numerator. Okay, looking from here to here, I'm missing n plus 3. Okay, so now I'm going to multiply my numerators together, and I get negative n squared. Let's see here. Outer, let's see here. That would give me a negative 3n and a negative 3n and a negative 9. So that would be negative n squared minus 6n minus 9. Okay, now what I want to do is I want to distribute this minus sign to every term in the numerator immediately following. So this becomes a plus, this becomes a plus, plus, plus. All right? Now, let's combine our like terms. So we have in the numerator n squared. I've got like terms here and here, so that's a negative 3n and a positive 6n, which gives us a positive 3n. And then a negative 9 and a positive 9 gives us 0 over n plus 3, n minus 2. Okay, so now let's factor our numerator. Let's factor out the n. And look at that. They have some like factors that we can get rid of, that we can cancel out. So my numerator is simply n. My denominator is n minus 2. And we're done. Okay, so what if you have something that looks like this and you're like, what? How can I take that 3 away from that? Well, remember that 3 is just over 1, so don't freak out over that. And I can't factor the denominator, so I'm going to rewrite this as 3 over 1. Okay? All right, so now what is my LCD? My LCD is c minus 2. Okay? So from here to here, I'm not missing anything. So my numerator does not change. Okay? From here to here, I need to multiply by c minus 2. Okay, so I end up with, in the numerator, 3c minus 6. Now, let's distribute our minus sign. And my numerator, my like terms, are 5c plus a negative 3c, which gives me 2c. And then I've got positive 4 plus positive 6, which is 10 over c minus 2. Let's factor the numerator, see if that helps us. It doesn't. So this is it. This is as good as it gets here. All right, look at this hot mess. Ugh. All right, let's take a look at it. I love doing stuff like this, though. All right, so the only thing that can be factored is this one over here. This can't be factored, this can't be factored. So I'm just going to factor it right here, u times u minus 1. Okay, so it looks like my LCD is actually this whole piece right here, because this matches that, right? And this matches this. Okay, so my LCD is u and u minus 1. Okay, now let's take a look at going from here to here. What am I missing? I'm missing u, right? Okay, so I want u over u, which would give me a 2u squared. From here to here, I'm missing the u minus 1. So I'm going to multiply the top and bottom by u minus 1 over u minus 1, which would give me u minus 1 in the numerator. Remember, 1 times u minus 1 is just u minus 1. Okay, going from here to here, I'm not missing a darn thing, so nothing changes. Okay, now we can't, first thing that I would do here is I would get rid of this subtraction sign right here by distributing the negative. Okay, so I would change that to a plus, I would change that to a minus, and I would change this to a plus. All right, so now our like terms. This doesn't have anything to combine with, so I'm not going to combine it with anything. So I've got 2u squared. Okay, my next like term will be positive u plus a negative 2u gives me a minus u. The next like term gives me negative 1 plus a positive 1, which is 0. So those just go away. They become 0. Now let's factor the numerator to see if we can cancel some like factors. And look, I can get rid of these u's. So I am left with and that's it. We are done. Okay guys, that's it for this video. So if you have any questions or need any help, you know how to find me. I'm here for you. You're not alone in this. Let me know and I'll be happy to help you, and have a wonderful day.